Testing, 1, 2, 3. Is that right? Is it working? Yeah, I'm louder than Gary's going to be, but whatever. He said his max.
Making a video, DaftScience and such. Yeah. I'm busy lately, unfortunately. Not too many comments, so I'm not really behind. I really don't like not making a video for a couple of days. Seems so unusual. Yeah. So anyway, not too many comments, so we'll do some of that, and then maybe a pyrrho video or something to provoke some sort of conversation. And, I mean, clearly that's the objective here, is to try to argue these points. And I'm clearly attempting to convince you to be reasonable and recognize that the evidence for what most of conventional physics believes is really thin evidence. It's a story that's barely glued together. I mean, it just isn't quite right. And anybody mechanical kind of knows that, right? You're fitting pieces together and you're gluing them together, and you kind of know, well, it looks right, but it just doesn't, the angle isn't right, something's not quite right, and you just tell that if I glue these pieces together this way, it might look a little bit like it used to, but it really won't be really secure or right, because it's just not quite right. The surfaces aren't quite meeting, it isn't good enough. And a reasonable person ought to admit that what they've cobbled together isn't good enough, in my opinion. They should be able to say those words without feeling like they've, done something immoral. So it's the truth. It needs to be done better, and it needs to, especially at the foundation, is where it's kind of rotten. These simplistic notions of Heisenberg and Huygens and the whole bent space relativity, all acceleration is the same kind of nonsense. Anyway, so this comment I don't really understand. Kind of see a goat see. I think that's some kind of, that was some sort of website where, you looked up people's anuses or something. I really don't see, the point of it. Just wasting people's time. All right, pretty good explanations, especially blah, blah, blah. Who cares? What a loser. Why don't you try to get more viewer without insulting anyone? Because the most view. I mean, why don't you speak English? Oh, you're an anime character, you can't. You get, rather than your junk videos, some sort of laughy face. So Electric Boom does a video claiming that a Professor Lewin is wrong, and clearly knowing that it's going to create controversy and sort of just pretending he didn't know that's what it was going to do. So when he does it, it's not for views or because he thinks he can work it to his advantage or any of that crap. And then when it kind of goes a little bit south on him, that he says, oh, this is creating a little too much heat, he completely pussies out and basically thanks somebody for apologizing by saying, I'm sorry, you're as dumb as a flat earther. So the apology Professor Lewin made was basically saying, I'm sorry, you're as dumb as a flat earther. And Electric Boom said, I win. Yeah. And somebody shouldn't point out how that's really stupid. And because I do that, I've done something wrong. I just point out the duplicity of the critiquer who doesn't have the guts to stand by what he said, which is, you're missing something obvious. And Professor Lewin is clearly missing something obvious, that you can't measure passively the voltage in a system where there's a bunch of EMF flying through the atmosphere hitting your probe wires, that you're not going to get an accurate reading regarding the voltage if there's a bunch of force. Your probes are in the field collecting other forces besides the voltage you're measuring. I mean, it's obviously what's happening. And for Professor Lewin to pretend he can't understand that is hilariously stupid, and somebody should point it out. And again, but somebody with balls should point it out. Somebody who doesn't wimp out and pretend the controversy has been resolved when it hasn't. Professor Lewin isn't changing his rhetoric, and Electric Boom is clearly implying that he's not changing his, except he's implying that he is, in a sense. He sort of implied that somehow he was wrong without saying, by saying I'm right, but implying he was wrong, which is, again, just such a cop-out, jackass thing to do, and you're going to reward that by trolling me on a subject that's just so clear. You're proud of how Electric Boom handled it? You think he should say thank you for calling me as dumb as a flat earther? I mean, fuck. I mean, this isn't that complicated. You're just such an asshole. Flyora. Strange, but, welcome. I like your attempt. Whatever. It's not just an attempt. I happen to be right, and somebody has to be, and it just happens to be me. Big Think has posted a video a long time ago, so that's sort of a weird sentence. Obviously, they had posted it a long time ago. Yeah, exactly. It's an old video, and it's by pretty much, I think the guy's a string theorist or something. So even though he's talking as if physics needs to straighten up, his version of a straight line is still crooked as hell. So even though I agree that the video is interesting in the sense that he's kind of pointing out that physics needs somebody to fix physics, what he considers a fix, I think, is loop-de-doo. With a mathematician stating that physics needs a revival and that they are wrong and that physics needs a maverick or out-of-here approach. Yeah, you really don't have to be out of anywhere. You just have to be a little bit rational to recognize that they've never proven wave theory. Okay, waves happen in mediums. They've never proven space is a medium. They've never proven photons aren't exactly what they appear to be, which is quanta of energy that moves from point A to point B, and the quanta moves, you know. So I admire your ability to counter-argue the indoctrination. Period. It should be there. Again, I'm not really looking for admiration. The point is that I'm making arguments, and people should either be, they should either say, well, I don't see your logic, or they should counter-argue and say how, no, the evidence really is strong, not weak, and that your evidence, my counter-argument for how you really can explain this with physical dynamics. You don't need any extraordinary things. You don't need infinite little wavelets. You don't need complex wave theories, complex interactions even. That the whole thing is basically just momentum being exchanged, and it's usually exchanged 99.99999% of the time, and every real experiment kind of demonstrates this change in momentum. So, okay, whatever. Thank you, mostly. Probably. Partially. So, and that's it. At the end of the comments. So, yeah, so maybe we'll just move on and do this wavy thing of pyrrhos just to mock it as so superficial. Doesn't deal with any of the evidence and doesn't in any way do anything but hype a bunch of hype, just keep blowing the fake smoke of, oh yeah, we've proven it, we did it, we've demonstrated. No, you haven't done any of this. You haven't done any of it. So it's just all a pile of crap. So in line with his space is a thing video, this is just another bit of hype, propaganda.
Now, having demonstrated that space is a thing.
Right, so, he didn't demonstrate anything. There's no evidence he showed us of the thing, space doing something. No compilation of the evidence, no nothing. Just some sort of word game where he says the space has to create the dimensions that things move in. So somehow, if you have an open field, somehow the cow can't go anywhere. Where if there's no field created by the field gods, because the cow needs to walk on the fields, as if the fundamental elements of the universe are somehow dependent on roads. They're cars and they need a road to drive down. Some sort of BS like that. Hardly a proof, hardly a demonstration of anything. Just bullshit. Just pretend you made a convincing argument with a substantial amount of evidence when you did nothing. You're just the worst of the shyster lawyers who just say, look, I'll put up some pretty pictures and you'll believe me because I'll be kind and gentle.
Just like the color red is a thing. Properties are material.
The color red is a thing, so that wasn't even in the conversation, but clearly color is a thing only in the sense that the frequency is a thing. That's it. Now, how we interpret frequency to call something red, that's not a thing. That's not anything real. There's just the frequency, and it's different than this other frequency, and it's different than this other frequency, and our brains can tell the difference. The electrons can tell the difference, and therefore our brains can tell the difference.
Material things as well.
But obviously, a frequency of a photon isn't even comparable to nothing. So I mean, how do you say just like red is a thing? Well, red's made up of a photon and a frequency. There's more than one property it has. What are the properties of space again? Oh, that's right. They don't have any.
Or only properties by virtue of being things that can be sensed.
So again, I can't sense empty space. in a practical way. And every experiment we do playing with it, they're always kind of deceptive. So the Bill Gates guy has been talking about this same kind of subject of nothing and what it is. And he's brought up, the early days when they first did the, evacuate a cylinder, kind of making the barometer. And then they realized that, this isn't so much about the vacuum created, it's more about the air pressure. And yeah, if I put this thing in space, this thing I think that has a vacuum, well, that vacuum isn't going to mean anything in space. And so it's sort of demonstrating that the nothing really is nothing. And it's always something that has to be the real, that's really dictating where something's going to be. It has to do with forces acting on it, not the absence
Hello?
of forces. But you can't stop a force.
Hello?
The fundamental forces can't be, well, no, I shouldn't say the fundamental forces. I mean, photons, I would argue, are a force, but they're obviously this more complex force with the electrons, with the frequency. But the elemental forces like magnetism and gravity are pretty hard to make a barrier to.
And measured, right? So, I've obviously demonstrated that.
So, this is what he's being funny. I've obviously demonstrated. No, you've obviously haven't done any of that.
I have
Conventional physics hasn't
demonstrated it.
demonstrated anything substantially. They have very weak evidence, very tiny shreds of it seems like, it kind of looks like, it's a little bit like, it's sort of like, but yeah, the evidence is terribly incomplete and insufficient. And clearly, if you're honest to the evidence, like with the slit experiments, then you recognize that photons don't behave like waves in the single slit, and they don't behave like waves in the multi-slits. And
Diffraction and interference in general are wave phenomena.
you're lying to say that it's just like wave phenomenon when it's really not, if you're honest to the evidence. But
No, it is just like wave phenomena. That's the only source of interference, including in diffraction.
you people really aren't honest, because you're on a mission to sell your propaganda. You've fallen for a doopy, stupid, wanky theory of unicorn bullshit, and you're trying to seduce everybody else into being just as stupid as you.
Nah.
As if, I don't know why. And again, I really don't know why.
Oh my
I
God,
don't
how
know
far are
why
we in?
this
15
mushy,
minutes.
bullshit means something to you people. It means so much that you will lie about the
Nothing
strength
yet.
of your evidence. Why are you willing to lie to defend this kind of, to me,
I'm going
really
at
silly notions of stuff
1.5
swirling and doing
speed,
all this
but
stuff with no
still.
force acting on them? They just somehow know to do this. How do they know how to do that?
Space is a thing. Now, some people could say, hey,
Things know how to wave because it's the result of covariant interactions, right? Like when one part of space interacts with its neighbor, that leads to wave-like behavior.
there's
In
an
general.
apple and a book on a tabletop. The apple brings the three-dimensionality. The book brings three-dimensionality. No, those have to be three-dimensional, just like that.
No, they have to be three-dimensional. So he didn't counter-argue. So somebody argues that, no, the physical material stuff spreads into the 3 dimensions. It moves. It takes up space in those dimensions. It doesn't need the space to provide an opening for it to move into. It moves.
So a three-dimensional object could move into a three-dimensional space that didn't exist. It doesn't need there to be three-dimensional space ahead of time. It brings it. That's a weird argument. It's almost relativistic, right? Where no, the distance between two objects has to do with their relative location. Without the objects, there is no space. Well, but when there is an object, there is a space. And considering you have sort of this objectivist fundamental reference point objectivism, certainly the space has to exist for the thing to move into it. I mean,
And claims the space. So there's no need for any mediating capacity to tell me I can go there. The book doesn't need permission from space to go somewhere. How did you argue that? How did you say, no, that's not the truth? That's right, you didn't make any argument.
Have colors from the set of colors. And if they're invisible, or if space had the potential to have an infinite amount of dimension.
Well, as I understand, nothing's invisible in any real sense, right? It can only be invisible to our eyes or perception, but
things can only be invisible to our eyes. Yeah, that's what it usually means.
clearly there's lots of things we know that are invisible to one instrument, but another instrument can see it just fine. So if it's already something we know exists, visibility is a kind of a silly notion. It's some property that's not necessarily very relevant, whether or not we can see it or not.
That's what someone is saying, basically. It's like, oh, the apple brings the 3 dimensions. Oh, so I could just take this 5-dimensional object and put it on?
So again, how are you going to explain the existence of 5 dimensions?
So there's no existence of 5 dimensions, but objects bring the dimensionality. They all just happen to be 3-dimensional. What a load of shit.
There's absolutely no reason for any rational person to see any room for any fifth dimension. There's no geometry for it in the real universe. We have circles, we have spheres.
There's no geometry for it in the real universe, right? Because real space is 3-dimensional. It has the property of being not 2-dimensional, not 5-dimensional, but 3-dimensional. That's my point.
You know, we have squares and then we have cubes. We have those things. Those things exist. Now you're making up pretend dimensions that aren't, there's no possible rational way to add them. There is no,
I'm not making them
they
up.
don't exist
You are
as
making
anything
them up.
but something you made up. There's no way to accurately create a fourth or a fifth dimension as a physical dimension. There's no geometry for it. So
There's no geometry for it because geometry is 3-dimensional. I mean, the 2-dimensional aspect of geometry is a cross-section of 3 and so on and so forth. We experience a 3-dimensional space. Fourth and fifth and sixth dimensional space are just mathematical constructs as far as we know. We experience in the real world 3-dimensional objects occupying 3-dimensional space, which is my point. 3-dimensional space is my point. Space is 3-dimensional. There isn't a 5-dimensional object in 3-dimensional space. They're all 3-dimensional.
you're just making it up as if, oh yeah, these are real concepts, right? I have a real thing that has a fourth or a fifth dimension. That's all a fantasy. It's like saying it has gremlin dust on it, or Sasquatch fur. It's meaningless. Even Sasquatch fur, I shouldn't even say that because that's a rational extrapolation on some sort of man/animal, something real. There's no
Interesting.
realness to a fourth dimension.
Table and there's 5 dimensions there. I don't think so. So how
Yeah, I don't think there is any. This isn't a rational comparison, but clearly I could argue I could take something that's only moving in 2 dimensions, and I could say, well, if it moves in a 3rd dimension, it didn't need somebody else to create the dimension. The dimension was created by its capacity to move.
Well, didn't you
could
say
have a car
that
can only move on
cars?
flat Earth, and then you could give the car levitation capacity, and then you can go into the 3rd dimension.
That's right. You were saying the car is 2-dimensional because it goes on the surface of the Earth. Yeah, but it looks a little 3-dimensional. Weird. Looks pretty 3-dimensional to me. Oh, for fuck's sake.
Well, if it moves in a 3rd dimension, it didn't need somebody else to create the dimension. The dimension was created by its capacity to move. So you could have a car that can only move on the flat Earth, and then you could give the car levitation capacity, and then you can go into the 3rd dimension. But I don't have to create space. Doesn't have to provide the car with the ability. The car has to have the ability.
The car always was in 3 dimensions. That's the secret here. The car was always in 3 dimensions. That's how that works. How did it move into that 3rd dimension all of a sudden off of the surface of the Earth? Oh, well, because it was always bumping up and down. It was always in 3 dimensions.
So again, you can demonstrate anything.
you demonstrated that?
Oh, you can demonstrate anything. No, you can't. You can't demonstrate your idea.
To the point where any reasonable, rational person would agree.
Yeah, well, again, so what is that, comic rhetoric or something?
Yes, that was comic rhetoric. You got me. Oh, and you fell for it, I guess.
What would compel me? So you're saying I'm irrational if I don't get how profoundly meaningful your non-existent art?
Yes. Yes, that is what I was saying. It was rhetoric. It was also sincere. You're not rational is what I'm saying, Carrie. Because yes, of course you're going to reject it.
Argument was your absence of any evidence or reason for me to believe it. There's absolutely no reason to believe that throwing this from one hand to the other requires the atmosphere to participate in any kind of substantial way. This just pushes it out of its way. It doesn't need permission to go from here to here. It doesn't need some space to say it's okay. It's just horse shit.
It doesn't need space to go through. To go from one hand to the other, the space in between it doesn't have to exist or be empty or anything. That's what you're saying. Well, I disagree. I think to throw something from one hand to another, there does have to be space in between them. And by all normal language, no one would disagree with that. Of course, there has to be space open in between. If it's filled, or if there is no space, if there is no space between the left and the right hand, then the left and the right hand would have to be in the same space. They'd be at the same place already. Obviously, there's space between the left and the right hand. Your position is no, obviously, there is no space between them. Well, I think it's pretty much more obvious that there is space between them, Gary. And anybody would say that was thinking rationally.
And you know it's weak. And yet you're too insincere and too dishonest to admit you don't really have an argument. You really can't say it in any kind of rational, reasonable, logical context. This is why you should believe what I believe. Because there is no reasoning to why you believe it. You believe it for some other reason. Not because it's reasonable and rational. You believe it because somehow you want it to be true for some dopey reason. And it's likely a religious reason.
I would like to extend
Projection.
my statement to the fact that everything certainly must be
Projection.
because
Everything certainly must be. Again, everything I see isn't wave-like at all. I'm not wave-like. This battery's not
You're very wave-like.
wave-like. Everything
Well, the battery's definitely wave-like, sending out a current of electricity as waves.
around me is not wave-like. So what are you talking about? Everything must be wave-like. It's complete
Everything around you is wave-like. That's why you're in a totally new location.
horseshit. I mean, why are you saying something like that when, like I said, I don't encounter this wave-like crap anywhere until you have a fluid somewhere where you have,
I don't encounter this anywhere until you have a fluid like water and, let's say, lakes and rivers all the fuck over in my shower and bathtub. Yeah, you've got some wave-like phenomena. It's not so weird. Waves are so weird. It's phantasmagorical to have waves. No, they happen in water all the time. They happen with sound. When you hear something, that's a wave, Gary.
pressure that moves through it. And in every one of those cases, none of that pressure moves without losing velocity and intensity. Something that doesn't have anything to do with what force does, because force doesn't lose any intensity or velocity. So there's nothing.
Well, the force gets absorbed and it does lose intensity. Its result loses intensity. I mean, what the fuck are you trying to say? Oh yeah, you're making shit up. And we're only 20 minutes into an hour. Well, you'll probably finish with my part, and I can finish with you.
Really
Ridiculous.
comparable. So why would you say something silly like
Ridiculous.
that? Wave-like. I don't see anything.
Because
wave-like,
everything
really.
is wave-like.
And even when there's a wave, it's not really.
Yeah,
like I
because
said,
you're
it's in a
blind.
medium, it's not really what people think of as a wave. It's just pressure moving from high pressure to low pressure.
Oh,
if you have a phenomenon,
and phenomenon meaning what? Just more mushy
something
words.
happening.
You mean a subnuclear phenomenon, or
A
atomic phenomenon,
phenomenon.
a molecular phenomenon? What level of the universe is this phenomenon?
let's say you had a phenomenon where there was a two-dimensional representation of it. Hey, it
So a phenomena with a two-dimensional representation. So
creates circles. And there was a three-dimensional representation of it, which was like, hey, look, all of it together is a sphere.
And again, you could just do this with squares and cubes. So what? Again,
So if you had both phenomena, something that looked like a sphere in some situations and something that looked like a circle in other situations, then you would assume that the real phenomena was a sphere and the special case or cross section was the circle. Why? Because a circle is a part of a sphere, but a sphere is not a part of a circle.
and again, why is this some sort of a insightful game to play? 2 dimensions versus 3, flat book versus pop-up book. I mean, what is it that exciting? No, I don't think so.
You would say it was three-dimensional because the three-dimensional thing, you could take a slice of it and explain the two-dimensional thing. The two-dimensional thing, you can't take a slice of it. There's no part of it that explains.
Sure, you can. You take a regular circle and you slice it. You'll get different diameters. as you slice it. And the same with a sphere. You slice it, you'll get different diameters.
If you take a circle and slice it, you get line segments. If you take a sphere and slice it, you get circles. If you take a four-dimensional sphere and slice it, you get spheres. What's not to oh yeah, you don't want to understand.
So where's the mystery?
It's a three-dimensional thing. So it's a higher dimensional thing that works. It's like in that old cartoon Flatland. I think it was a book too. But it was this great cartoon. And
Again, just more subjective, bullshit, useless opinion.
Right, mentioning there was a movie about this concept is what?
Great cartoon. Oh.
this shape lived in a two-dimensional world, and he meets this circle, and the circle can grow bigger and smaller. He says, "Look, I'm actually a sphere. I'm not growing bigger and smaller. I'm just going through your dimension. You see a two-dimensional slice of me, which how would he see? How would he get over to see it?"
Yeah, who's doing the slicing? So again, more just nonsense.
Who doing the slicing? Okay, in Flatland, there is a two-dimensional world, and if you come in contact with it, then you interact with the plane, and so the slicing is natural. Oh, I guess he hasn't seen it.
Right? I mean, you can change perspectives. Yes, and with 3 dimensions, you have more perspective to change. So what?
But anyway, and
So that's the relationship between a lower and higher dimensional space?
it's something like that.
It's something like that. So now I guess what he's trying to say is that a photon is something like that. Somehow it's spreading in.
Yeah, a photon is like that because what it looks like is that the photon goes out as a ripple, a circular ripple, just like any wave front. But then what we see is this cross section where it's just one photon next to another, all these potential photons. So yeah, it looks like a ripple, and there's a cross section, which is a slice of the ripple at an orthogonal 90-degree angle. You don't, you didn't already know this?
3 dimensions. You know, that it's actually waving in 3 dimensions. So there's a bunch of energy going in all kinds of directions, but the photon never lands in any of those locations. It always just lands in one location. So even though it dispenses a bunch of energy going to a bunch of places, it never goes, which doesn't make any sense. Doesn't make any sense to me.
Well, it's the part where it looks like it's a cross section. What goes out is this one pattern, and what we see in terms of a speck of light is this cross section. As if that's why some people say we're in a multidimensional space.
At all. That somehow you can, you know, whatever, send your signals through your medium for free. Okay, it doesn't cost you any energy. On top of that, your medium will allow you to sample all locations and then somehow decide which location you're going to go to. Yeah, well, that's your bullshit. By some magical mechanism where the photon creates a copy of itself to interfere with and then decide where it's going, which doesn't make any sense. And again, decides based on a probability equation where somehow it has to know what it did all the other times it did it. You know, how does it know? Does it roll dice to decide? Does it flip a coin to decide to get the probabilities right? What device does it use to figure out how to get these probabilities correct?
I mean, we
know in water waves the device used is fatigue. You know, the reason why there's more light in the center and less light as you go out further is fatigue. There's less energy. That's why there's less light.
with so when you shine white light,
Less waves, and I meant to say, obviously.
Fatigue. You mean how organized energy, information is how it is dampened into by friction and things into it's turned into noise. What are you talking about? Oh yeah. Oh yeah, you don't understand physics. You're not talking about anything.
I'm arguing that
I
light isn't a
see.
wave. But in water waves, the reason why the pattern gets, the probabilities created in that pattern, those probabilities are created because the amount of energy going those longer distances is less energy.
Through a slit, you see diffraction. Through
So you don't see it in water waves in the sense you don't see. I mean, yes, you see diffraction in the sense that you see a wave front. You put a wave in, the wave continues to do what it was doing before it got to the slit, which is spread, okay, and weaken. Now, in light, all you see is a photon land at a specific location. And again, you don't have any explanation for how you decide that you're going to make two photons with one single slit, and it's completely arbitrary. They just invent a fake middle. So it's like they're saying that a million of something is going to be created, right, in a confined space. And what they do is basically say it's always an odd number of infinite things.
Mr.
So there's
Natural
no
has
infinite
showed
amount
up.
of little wavelets that ever comes out to be an even number, because they always want to put something right in the middle so they can create two separate waves. Or you could say they always go with an even number, so there is no middle. So it always has to be two clumps, okay, because they eliminate the possibility of there being an odd man out. And that's all they've done. And it's completely arbitrary. It's just made up. It's just erroneous to the one purpose, which is create fake evidence, create an argument that somehow makes this work. So their argument is this fake theory that they never
Projection.
demonstrate there's any hope of it ever finding any proof for, that an infinite number of little waves are created in front of a
Do I-
wave, okay, to create the next wave.
Am I
And
audible? Yeah.
that there just happens to be
Projection.
the right number. So there's no middle. So they have to cut it into two
Projection.
separate waves. And that's it. It's just completely made up. There's no absolute rational reason why
Is
a single wave
view.
goes in and two waves come out. No reasoning for that.
yeah.
Just a fake notion of we're going to force it to happen. We're just going to make up an excuse to argue that everything.
Well, when the slit happens, one wave goes in and a little tiny chopped off section of wave goes out, and it goes out. And it's not two waves. That's just an approximation. The Huygens principle says that every point along the wavefront that was cut off there is like a little point source. So it ends up spreading out. But if to add up an infinite number of point sources, that's computationally expensive, and it's very similar. The major tone of its shape is set by the two endpoints. Why? Well, because that's the part that is at the edge of where it got cut off. Everything in between is a little bit more like a regular old wavefront that wasn't cut off. Not super complicated to understand.
It
Gary,
cancels
you
out except
just
for this middle thing, and therefore there's two waves. No, it's just a contrivance.
prism, you see this refraction. It makes a rainbow.
Right, and no one's arguing the existence of the rainbow or the refraction. We're arguing what's the cause and what's really happening. Well, we know that what's happening is the light is being bent by a specific amount based on its frequency. That's one of the components that's going to dictate how much it spreads. And then the thickness of the glass, in a sense, will also dictate, because the thicker the glass is, the more time the light spends traveling at the obtuse angle, and before
Yeah.
it's put back to its normal angle again when it leaves. And we know that this is a phenomenon that happens inside the glass, happens on the surfaces, the reflection. It doesn't happen with a whole bunch of wave interference or any of that kind of crap. It happens right at the surface. And right at the exit surface.
You know, it
That's when the
also
angle changes.
happens depending
going
on the
through the
distance
surface.
between the
Those are wave
thickness
phenomena.
of the
Two slither-
glass.
Again, they're not wave phenomena in any sense except you say so. The evidence
Well,
doesn't scream
they
it
are.
over, as I keep pointing out over and over again.
Well, the
Depending on what
evidence
wave
not
experiment
only
you look at,
screams
there's
that
nothing
it
at all similar. So again, in single slits,
specifically
water waves behave
proves
just
it.
as we would expect. They just create one wave. It doesn't interfere with itself, and it doesn't create an interference pattern.
does.
With the photons, it does create an interference problem. So the two experiments are not
No,
alike.
waves
In a double
in
slit, yes, you get an interference
water
pattern
waves
in water,
will
but what
create
you don't get is an interference
interference.
pattern that's inside an envelope of the single slit pattern in light.
It's
So it's not the same pattern.
well
And then with multi-slits, you get nothing
demonstrated.
similar. Again,
All waves will
and you're saying this is convincing evidence. I'm
create
saying no, to a rational person, this is not
interference
convincing
patterns
evidence.
with two sources.
I have no reason to say, yes, I'm so convinced. What do you think I'm not convinced
Including
about? You think there's
slits.
some reason I'm not convinced except for
A
the fact
slit
that there's
is
no
a
evidence
way of
convincing me,
creating
and that
two
your theory is dependent
sources
on me
out of
completely
one
making something up,
source.
not being able to see it. No experiments demonstrating it. To believe in some dopey Huygens thing of an infinite number of waves. I'm supposed to believe there's an infinite number of something in this space.
It's not
And you're saying
an
that's your
actual
best
infinite.
logical shot. You're saying that's good reasoning.
Huygens isn't saying there's an actual infinite because there's a finite number of water molecules or something. Huygens predates the quantum stuff, and it's just about waves. And in water, ultimately, there is a finite amount, but it's so tiny, the finite amount, that it follows the mathematics of continuity, except for when you get down to this tiny size. And, those are adjustments you can make to the calculation. But basically, the water wave is, since there's so many trillions of molecules, from our frame of a reference, the continuous math proves quite accurate.
Good reasoning is believing in the story of the infinite number of little waves. That's not good reasoning. It's certainly not good physics.
Interference, you see a wave phenomenon whenever you shine a bright light.
No, so whenever you do that, you don't see a wave interference pattern. And again, as I've argued with the radar experiment, you can use exactly the same geometry and recognize that, no, the only thing you did was jam the two signals. You jammed the radio. And that's why you have places where there's silence and then
Jamming the radio where there's silence is a wave phenomena. You don't get that, but that's absolutely what it is. There's no other way. You don't, if you jam a radio signal with positive particles, then it's going to be saturated at maximum volume. That's how you would jam it. And we're talking about jam, which is definitely a way you can jam a radio signal, but we're talking silence, jamming it with silence. That's only, you can't add more particles and get silence. Only waves, only the wave phenomena with a negative trough can add to silence. Obviously, Gary. Obviously.
in places where it's twice as loud and in places silent and twice as loud, it's because you're jamming it. And when you put an audio track on the base signal, the reason why it's twice as loud is because of the artifact of modulation. Modulation does that. It creates 4 times the amplification of the signal.
Light through there. Now, when you lower the energy down to the point that you're dealing with this Planck constant issue.
So again, this isn't about lowering energy down. It's about lowering the number of photons. So, this is supposed to be a guy who defends Richard Feynman. Well, Richard Feynman would hate what you're saying here, because clearly he understands that you can't lower the intensity of the photons at all. They're always clumps. They're always hit with the same impact. All you can do is change the number of them. So again, it isn't anything like a wave, and he made that explicit point. This is evidence against wave theory, is the very fact that you can't tone the photon down. You can't turn it into half a photon or a quarter of a photon. You can't make a weak or strong wave.
Of whole units of energy, you start to see just a speck of light at a time.
Yeah, everything's made of the pieces that make it up. So clearly any pattern of light is made up of a bunch of photons. I mean, the image on my screen is made of a bunch of pixels that are constantly being updated. This isn't brain surgery kind of stuff. I mean, who are you fooling? Come on, light. Why the hell aren't you turning on? So again, this is just mush. To pretend that's insightful somehow. They've done the experiment with single photons. Single photons land as individual clumps. They're clearly not interfering with each other in the two-slit experiment, so you have to figure they have to somehow be interfering with themselves. And that's where you get into your silly story that the single photon somehow knows to split into two to go through the two slits. And then you have the contradiction where when now the split photons go through the single slit, somehow they don't Huygens now, because then you'd end up with 4 waves. So somehow single slits don't create the Huygens effect. So, it doesn't fit. It's just garbage.
The particle, the evidence of the particle. You never see the particle shooting by, but you see this evidence of the particle.
Yeah, we all see only one thing, the evidence of the byproduct, okay? We don't get to see the product being made. We don't get to see the explicit cause. We just get to see the effect. And the effect can simply be described as the simplest pattern you can create, on, off, on, off, on, off. And they say every time on-off happens, we have to believe it's wave interference. That on-off can't be created by anything else. And that's how dumb or simply stupid their argument is. It's that narrow-minded, it's that pathetically rigid and irrational. It's just irrational to argue that you somehow have proven that every on-off pattern that the universe creates is created by wave interference. It's just irrational for you to propose such a thing, to argue such a thing.
I liken that to if a small tsunami, a rogue wave, is coming up to the beach, and it comes up and it hits the boardwalk, and it knocks just one board off.
Well, that would be a phase argument then, right? Because the wave is traveling in the sense that the pressure travels. So if it's moving towards the boardwalk, it's just going to annihilate all the boards as the pressure wave passes through. Now, you want to argue it's coming at some kind of angle. Well, I don't know. But I mean, it's just crap as an argument. All right, we're not talking about what board was nailed on. We know the board that's going to fly off isn't going to fly off because the wave hit it harder. We know it's going to fly off because it's a weaker board or some other reason like that. So there's going to be a physical reason for one board to fly off and all the rest of the boards to stay there. A physical reason. And you're the ones eliminating all the physics. You're saying...
No, there is still a physics. That's the weird thing. The wave hits the whole boardwalk. It seems like why not bump off all of the boards or half of the boards or even if it was 1 in a million boards and there was a million boards, okay, just one board, but what about two? What about no, but there's a conservation of energy and just one board gets knocked off. That's the puzzle. And that is what happens. So we have to answer that. You can't just go,
saying that the surfaces in the light experiments can't possibly be responsible for the effect. You're basically saying they're solid surfaces, they're benign, they don't do anything, and the photon has all these magical powers. When clearly the logical explanation is, just like with the boardwalk example, the board that flies off is because the board is weaker. And in the light experiment going through surfaces, the light is deflected because the surface is a complex area of atomic structure, and the photons are in fact being diffracted, just like they're being diffracted going into a surface, refracted. The diffraction is just like
The funny thing is you don't understand what diffraction or refraction actually means, and I know that. So how am I supposed to take seriously when you use those words? I think I shouldn't. I just think I shouldn't, Gary.
the refraction. It's obeying a rule. And the rule is a physical circumstance created by the surfaces, not created by the photon.
Splashes against the boardwalk, knocks one board off. In the morning when they come down there to look at the boardwalk, they're like, oh, look, it looks like a single cannonball must have hit this board. It just knocked it clean off.
Well, we know the photons always land as single cannonballs. So again, they don't do anything like a wave.
No, we know there's a wave, and for some reason it only knocks off one board, and then you say it must have been a cannonball. No, it looks like a wave that knocks off one board.
The wave doesn't spread, it doesn't get weaker, it doesn't do any of the things that waves and mediums do. So it has nothing.
It does spread. I don't know what you're talking about. It does spread. That's the whole fact of it's not just two little slit columns. When it goes through a slit, one or two, if it goes through one, it spreads out. That's the diffraction effect. And you say it doesn't spread. That's the diffraction effect. Yes, it spreads. That's the primary one. The diffraction lines are way subtle. What's not subtle is that it spreads. You're just so full of shit, Gary. You need to, I mean, come on. Be more honest about the basic fucking facts. This is ridiculous. Or go back to something where you understand things better, like IRV. Jesus.
In
Pathetic.
common with them in terms of speed,
It's
momentum,
pathetic.
are again just physical movement in the sense that we know
I
of no
expect better
medium
from
wave
you.
that travels to all the locations and then somehow collapses and
just
goes to one
shows I'm
place.
an
Somehow the
idiot,
wave
but
just
still.
disappears. All the movement in the medium somehow just vanishes and never goes anywhere. So you have the perturbation in the medium, and somehow the medium, when it gets
Okay,
near an
look.
object, it disappears.
Perturbation. Perturbation. There's no such thing. Please just change to the right word. Perturbation. Perturbation. Not perturbation. Perturbation. You're talking about things that are getting perturbed. Perturbation. Not perturbed. Not perturbed. Perturbed. Perturbation. Okay? Fucking perturbation. For fuck's sake. Please. Perturbation. Perturbation. Not perturbation. 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 Perturbation.
It says I'm not going to hit it. It just magically goes away. So the momentum disappears. That's your theory. You're arguing that momentum can just disappear.
No, I believe in conservation of energy. I absolutely am not saying perturbations just disappear. No, it's energy is conserved. You must be misunderstanding my position. What a surprise. What a big surprise. Oh, I'm surprised you misunderstand my position.
It's nonsense.
The rest of them are in
Projection.
place. Now, the only mystery in this right now, to use this.
Look, they took them.
Now, my video is 6 minutes long. Okay. How far are we now? I don't even know. Let's see over here. Does it say? We are like, we're 45 minutes in. He's covering a 6 minutes. There was like, I don't know, 5 or 6 minutes ahead of time, but now we're in 38 minutes. So that's 30 minutes on my 6-minute video,
hundreds of years
where
to
I
play
was
with this
totally
thing.
right.
Come on, where is this light?
Yeah, where's the light?
I mean, it's a motion sensor. It really should. It really should be able to pick
You
this up.
should
Oh,
be
it
able to
does.
clap.
I
Isn't
really
it a
should indicate.
clapper?
I don't know. Anyway, just being stubborn, I guess. Termites, whatever.
Like you.
Yeah, where was I? Yeah, damn it, I lost it. Well, anyway, I've probably already made the point. It seemed the point I wanted to reiterate.
Metaphor is why just one boardwalk board?
Right, again. So he's going to try to figure out how he's going to give this knowledge of probability to the photon. And somehow the photons can figure this out by doing wave experiments or geometry experiments or any of this. And again, we already know that this happens right at the surfaces. I mean, instantly at the surfaces, this bending takes place. It doesn't take any time for waves to go interfere with themselves in some location or any of this kind of garbage. And again, where does all that extra momentum go? If the waves are doing all of this, how do they just turn the momentum off in all the wrong locations? It just doesn't make any sense.
The answer would be, well, the probability.
And again, in water waves, the probability is dictated by the fact that the further away you go, the weaker it's going to get. So, because the force is diminishing. So we know in the water wave experiment, if you could make the energy like a photon perpetual, that is lossless, that there wouldn't be any probabilities, would be even. There wouldn't be a declining probability. And in water waves, there's a declining probability because the waves get tired. In photons, what's the explanation? Because the photons don't get tired. In my opinion, the only rational explanation is that at the surface, the probability is decided, and it's a known probability that it's less likely to hit 7. It's hard to hit 7 electrons than it is to hit 6 or 5 or 4 or 3. And the more you hit, the more you deflect. And that's why the probabilities diminish as you go further out. There's a reason, a physical reason. And it's not consistent with why it happens in water waves.
The probability was at one boardwalk, and so one got knocked. Well, but why would a wave hitting the whole thing have a probability?
So we have no evidence that happens with water waves. There's no evidence that the water wave hits one board harder than the other boards or any of that crap. So
No, that's a wave example. Because you can't send out 1 photon's worth of a water wave. So that's what waves are really like. But also when you send out light waves, it's also like a water wave, and the whole thing of turning the light down till just 1 photon comes out, you can't even do that with a regular light. You need a laser. And I don't get what water waves are a wave you can see, and so it's a classical wave because Huygens and a lot of wave mechanics is about classical waves, like water waves or waves in a tank of oil or whatever. And that's a regular classical physical thing, and light follows that, except for when you get it down to such low energies that this Planck minimum energy comes into play. And when the Planck minimum energy comes into play, you start seeing these phenomena, of single photon kind of situations. And that's the weird part, right? But that's what we see.
he just sort of implying something that isn't true. There's no information in the wave that decides which board pops up. That's decided by how well the boards are nailed on the boardwalk.
Even if there was 100,000 feet boards in the boardwalk and it was 1 in 100,000, it could be 0, it could be 2 or 3. And in fact, this kind of...
So more bullshit, just talk. I mean, this has nothing to do with any real-world experiment, so he's connected nothing to a real experiment, connected nothing to all the experiments, that is, recognizing where his theory is consistent, where his theory is inconsistent. He's just ignored the inconsistencies, and it's just selling...
Well, my theory has no inconsistencies. Where there's inconsistencies potential, I don't have positions yet. So where it's clear where the evidence points, then I'm correct.
Hype.
effect you do see with probabilism.
Your face is hype.
So the weird thing about the puzzle part, the riddle, is just that there's a covariance.
So the point I tried to make before, it uses this word "weird" part. Again, this experiment's always been weird. It might remain weird for a while, because again, it is an unexpected result in the sense it's against your intuition saying photons shouldn't be bent by anything because they aren't bent by anything. But clearly, if you understand there's electrons near surfaces, okay, yeah, photons do hit electrons, and you can do Feynman diagrams for the implications of that. The energy goes in, the electron, if it's in tension, if it's already connected.
You could do Feynman diagrams, which are entirely diagrams of quantum mechanical processes, and you could do them in such a way that they're not quantum mechanical processes. Yeah, why do you want to co-opt Feynman diagrams? Oh, because they're cool. Let's look at what a Feynman diagram is compared to your system. Let's see.
To something, then yeah, it's not going to be hit and fly free like a cue ball on a pool table. If you tie the cue ball to a string, or you put it with rubber bumpers against it, then where your photon is going to go is going to be different.
It's right. Variance is the amount of like randomness, error, you could possibly say, or entropy in a measurement.
Again, so none of this has anything to do with the probability. We know it's a very consistent, and we know that it's either this. I mean, it always ends up being the same. So again, there's no unreliability in these results. They're always really consistent. It's either 3 degrees, 6 degrees, 9 degrees, 12 degrees. There's very little variation from those themes.
This is the variance of data. Covariance is when neighboring values have a correlated noise. Their errors are actually correlated, right? So
again, the noise in any of these experiments usually
you're not gonna get this.
Has to do with the fact that we don't use a laser beam that has one single frequency. It might look.
The error has to do with the fact that any measurement will also have some amount of error.
Red, but red means it's 720 nanometers, or it's 685, or
If you measure with a yardstick, you will have an error of 1/8 of an inch or 1/16 of an inch, depending on your ability to be careful reading the measuring stick and depending on the marks on the measuring stick, which basically can't really be less than 1/16 of an inch.
It can be in a range of frequencies, and that's where you're getting the little bit of fuzz and blur. But the more precise your frequency in, the more precise your frequency out in terms of the very sharpness of the angles.
the probability of that
Nonsense. He just didn't say anything there.
wave knocking a board off was exactly one board's worth of probability, and it knocked off one board. Now,
so again, there's no evidence that water waves do any of this probabilistic board knocking.
Well, water waves. No, I'm talking about fucking light and talking about particle physics. Waves in water is how waves work. And waves in the electromagnetic field or the electron field is how electrons and photons work. With the weird part being that if you turn the energy down way low, so you just have one photon or one electron's worth of energy and you get a speck at a time, you also have the particle phenomena because of the quantized energy.
Knocking, so that's just more nonsense.
See, I know you're smart enough to get this and that you're refusing to get it. You don't want to get it. You have an ulterior goal, which does not allow you to accept understanding something well within your ability to understand.
And again, the idea is that in water waves, the interference pattern is really an up and down. So it's up and down, more aggressive waves or no waves. So it's not like the photon at all in the sense that it's twice as much.
Given that it's jostling between water molecules instead of the very fabric of electromagnetic spacetime, yeah, a little bit different. Also different, you guys. And oil waves are different, and air waves also different.
Energy and twice as less. I mean, complete zero. Where the other, so it goes high and it goes low, the water. High, low, and then there's a part that just stays consistent. So it's not really a parallel to what photons are doing, because we know there's no such thing as a negative photon. So in that sense, it's not consistent again. And again, we also know that the energy that was going to the place that's neutral, like in waves, it's not, it's truly neutral. It's not either low pressure or high pressure. It's not a zero. It's like the pressure would be a 3, and then the wavy part would be 3 and minus 3 or 0. So that would be the extremes. So again, there's no parallel here. Water waves aren't the same, and the reason why it gets weaker as you go further away is because the wave traveling through the medium it's absorbing all the energy, and that's why there's less movement over here. There's not less wave. The waves have less amplitude. Not like a photon at all.
Wave came up and it was not, it only had a 100,000th of the strength in any one point that it takes to knock off a board. It wouldn't knock off any boards in classical situation. But in the real situation,
Here's where I'm describing the classical versus quantum situation with the difference between a water wave and a photon or quantum wave, and Gary probably will just slide right through it or make a distraction in a totally orthogonal direction. Let's just see. I haven't seen this before. I just watched this cold with you guys.
somehow it can come up with this sort of weak probability.
So again, there's no, like I said, in the wave theory, there's the probability is just tied to these certain locations. That's part of the probability. But the fact that it's a declining probability in terms of amplitude and total amplitude in the photon experiment can be understood that, yeah, that's just because it's less likely to be bent more. Bending requires structure.
No, this is the likelihood of having enough energy to knock off a board. And the fact is, it can knock off any board. It can knock off the likeliest board. It can knock off the least likely board. It's more likely that it knocks off a likely board, but it can come up knocking off the least likely. Just like when you roll dice, it's most likely to come up a 7, but it can come up a 2. What's hard to understand about that? Oh, you have to understand that there's such a thing as probability and the statistics of probability, and that when you roll dice, any number from 2 to 12 can come up, but not with equal likelihood. And you don't understand those things at all.
And you can understand that hitting more structure is harder than hitting just one. Hitting a home run is more difficult than getting a base hit. I mean, it's that kind of logic.
Well,
Oh, I
probability
see.
adds up to 1. It'll go ahead and
It's
knock off
all
one board.
simple. It's
100,000th
baseball.
of the chance of each board.
So it's a non-existent experiment he's describing. It's not even valid as a thought
And your baseball's a non-existent sport too.
experiment. It has no continuity to anything real, and he's pretending he's explaining wave mechanics in either circumstance, water or in photons, and he's describing neither accurately or with anything called.
And you flunked science in school, so you're probably wrong.
Real evidence, and yet he's saying somehow you should believe me, even though I can't provide you anything called real evidence, and I can't even do a thought experiment that's bound to a model.
Because you flunked basic science in elementary school, that's why.
That's anything coherent to anything we know is a real model. I mean, a good model. So he's not even using a good model to pretend this is how things work.
I think wave mechanics is pretty straightforward and a good model. You disagree because you're ignorant.
Get knocked out. That's the only riddle. But it has to be.
Again, it's the riddle of the experiment is understanding what is really happening. And again, the multi-slit experiment tells you a lot about what's really happening because actual images
Yeah, that you deny, many things you deny.
end up being projected at the locations. So there's fewer, they're spread more, and further, faster, and there's fewer spots created. and they're actual images of what goes in through the multi-slits. So they're actually projecting the structure that goes in. The photons that go in are being replicated at the new location. Now you can't do that with wave interference because you ruin the image by pushing stuff. You create distortions. So you could never project an image with wave interference.
Waves, because a wave can be a cross section. A wave can come up to a boardwalk and knock one thing off.
So again, he keeps using a metaphor or analogy that has nothing to do with any physical reality on this planet Earth.
Right. There is no waves. They can't hit a boardwalk. The ocean doesn't have waves.
And it has nothing to do with a reasoned model explaining how the model is the reality. So he's
Right. But to do that, you need to explain flocks of birdfish that turn at right angles when they intersect a black or red checker piece. That's what you need to be solid and totally understandable by everybody.
He's done nothing reasonable here in terms of making a fair argument about what the evidence suggests. He's just making an argument out of hype and just using a bunch of the physicists agree with me kind of notion. I'm right because they say we're right. We all say we're right, so we're right. We don't have to defend this crap. We can just say it as if it's true.
The sand, there's a pattern of the wave coming. If a cannonball is flying in there and hits the one board and knocks it off, that doesn't explain the pattern that's left on the beach.
It does if you change where the cannonball's flying, okay, by having it hit something. So again, you're just pretending that slits, surfaces, create no interference themselves. They don't make anything in the atmosphere at all. They don't change the environment the cannonball's flying through. But clearly, if I hung a bunch of cannonballs from a crane, and then I shot cannonballs through that field of cannonballs held in places, you'd understand that some of the cannonballs would hit one of those other cannonballs and be deflected. Now, if I did it in a very precise way, like all the cannonballs were lined up in certain locations, I could probably create a very probabilistic pattern of impacts and deflections. And I might end up with a pattern just like the electron experiment with the single and double slit. The electron experiment creates very good waves because clearly electrons do bounce off of each other. So when electrons are forced go into surfaces, they're hitting the electrons just as the photons would. But when electrons hit electrons, they don't really hit each other. They bounce off each other's fields. So there's a much smoother deflection. And that's why you're getting a much smoother pattern. So all of this can be explained rationally, within the confines of
By someone, not you.
a nice mechanical universe without all this wishy-washy, mushy, everything.
I know a mechanical universe where water waves don't exist because water waves are so non-mechanical. Waves, not mechanical. You know what's mechanical? You know what's mechanical? It's when I bump into a guy at the bar and we shove each other. That's physical. Yeah, but waves are la la land. Sound waves, water waves, they're like a phantasmagorical, like believing in a unicorn.
Everything's flowing and waving in some medium that doesn't exist. You still
Is this really 53 minutes in? This is really the whole my 6-minute video turned into an hour-long video, which is now like an hour-long video of mine. That's ridiculous. Should I finish?
you have no explanation for how this medium creates the tension necessary to create a wave out of a simple perturbation. I poke it and somehow turns the
Perturbation. It's not even a perturbation. It's a perturbing Asian. Perturb, not perturbation, not perp. I have oh dear, oh my lord, I'm having a perp. No, perturbation. 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 Not not perturbation. Perturbation. I know it's not a big deal, but could you just please get this right? Perturbation. Perturbation. Perturbingation. Oh, yeah, I'm perturbed. You're often perturbation.
the poke into a wave. How does your medium know how to do that? And clearly, how does your medium contract the wave or
Through viscous interconnection. That's the covariant thing I was talking about. Through the fact that local points in space interact with neighboring points in space?
Count the wave or discontinue the wave? How does it know when I'm making this spherical noise in the medium? How does the medium know to eliminate all the sound except the one that's going to go right to this ear? The ear over here hears it. All the other ears don't hear a thing. How does it do that? You have no explanations for any of this. It's just such an extraordinary theory. You might as well just be claiming there's UFOs and you've seen them. And now you're sitting here and just telling me I have to believe it because
You're saying you've seen these little particles that turn left and right and act like fish?
you say so. But you don't have any evidence.
So QED proved my point.
So as demonstrated. So what did he demonstrate? Did he really demonstrate anything in these two videos? Did he?
Totally. Totally demonstrated space is a thing and that existence is a waves intersecting and then creating of which we see a cross section.
He really in any way show us any evidence of anything? He has some background pictures of water waves that for me don't say photon at all. I don't know how that says photon. And space is a heavy fluid that rolls and then collapses on the beach. I don't think so. I don't think there's any reason to believe that. It doesn't make any sense to me at all. It's not consistent with the evidence in any way.
Yeah, but you're obviously clueless. I'm gonna have to not watch the last 14 minutes of your video. Sorry about that, Gary. All right, cheers.